Hey, just so you know, we're live. Let's see here. Change my.
Now I can hear you.
All
Amazing
right.
what turning up the volume does.
Okay, you can hear me
Turn
okay?
it up. Turn it up.
Can you hear me okay now?
Yes,
Okay. Am I coming through clear?
very clear.
Okay, because I've had some microphone issues in the past week or so, which I don't think are solely on this end. I think they're Google Hangout related, but
I've
anywho.
found that if I have an external mic plugged into my MacBook Pro, this works fine.
Yeah.
The internal mic, not so much.
Well, see, that's the thing is I have an external mic. Of course, I run it through a mixer, and just occasionally it just doesn't work. Of course, I've restarted the Mac a couple of times here lately, and I've also updated to their latest and greatest version of the OS. So it seems like there have been OS 10 bugs here lately that have been.
Yeah, there's been more than a few glitches.
Yeah, they haven't been highly publicized like some, but yeah, you're kind of like, I got to the point where I'm kind of like, I don't know if I want to hit the update button anymore.
Yeah.
It works. It works. It's not broken.
Yeah, I don't need to change anything. Oh, I have to upgrade to publish.
Yeah, exactly. Yeah, and they're getting pretty aggressive about it. They're like, it used to be kind of like you could say, well, remind me later, and now it's like,
Right.
You want to try in an hour?
We'll download this for you tonight. How's that?
Yeah, that's really getting aggressive. Which I guess is fine, but still, it's a double-edged sword.
It is.
Okay. Well, I did hit the start broadcast button, so we are live.
Yay.
So hold all your NDA materials until after the show. But I don't know why I hit go live. I was clicking buttons and stuff, and for some reason my brain said, go ahead and start it.
So we'll go live.
Yeah.
Hey, everybody.
Yeah, before I knew it, my finger was already clicking the button. I was like, okay, cool. So I'm here live by myself. Awesome. So I saw so while we're waiting for everybody to show up, I saw we're in that zone where if you want to submit your apps,
Yes.
you better do it fast.
It's due today, isn't it?
I
I
have to go.
think so.
I think so. Maybe so. Yeah. So.
Yeah, by midnight today, if you're going to have an app out by Christmas.
Yeah.
That's assuming you get approved the first time through.
Right. Yeah. Exactly. There's always that. What I am excited about is that there are murmurs, rumblings, word on the street where people are getting, a collective conversation of people being upset about the App Store and its processes and how hard it is to find things. And, I think we're due for some changes.
Yeah, but these rumblings have been going on since the very beginning. And the Apple process has always been somewhat painful to get through.
Yeah, I think though that what's going to happen is Google and maybe Amazon, to a lesser degree, are going to push changes that is going to drive Apple to have to make changes, right?
Yes.
And to some degree,
when those become a viable source for revenue for the developer, because I think you'll still finding that most developers are saying 80% is coming from Apple and 20% from all the other stores combined.
Well, I tell you, I think the one thing that's really going to start driving it, provided, depending on the success of the device, is iPad Pro, because a lot of the developers for business applications for iPad Pro are like, look, we can't develop a real
Right.
enterprise class business application on the current App Store model.
Yes. Yeah. And you can see that with a lot of the larger businesses saying that we're pushing updates every 2 weeks now. And basically it's still a month behind, assuming that they're going through the same process that everybody else is. Now, I don't know. Maybe these larger companies like Facebook don't have to go through the same approval process that Joe Schmo, a small indie developer, has to go through. But I think it's still the same case for everybody, that they're all getting reviewed this way.
Yeah. Well, and also the review times are a factor, but also just the monetization model, right?
Right.
If you go buy a desktop application today, you're still paying $20,
Yes.
probably at a minimum, maybe 15, but some applications are $50 or more. So when you're talking about a 99 cent one-time 99-cent sale, it's harder
Right.
for those developers to justify the.
I love the starting to see a lot of this around that. Hey, if you like our app, buy us a cup of coffee. Donate $5 towards it. You're paying more for a cup of coffee than you are for this app that helps improve your standard of living.
Right.
It's the system's definitely broken. We definitely need to see if we're going to continue seeing professional mobile developers, especially on the small scale, there's going to have to be some changes.
Yeah, I think it's interesting that some developers have learned to create entirely new versions of their app, right? So they just go out and they just say, okay, well, I'm done. I made a 99-cent sale off of this app.
Right. I'm not updating it anymore.
Yeah, I can push notifications to you and things like that to let you know about this. So I have a marketing channel. I have a way to communicate directly with the customer. But I'm going to create a whole nother version,
right.
and you're going to have to buy it again.
Come out with that new version and push it out and make money from it entirely separately.
And I think upgrades are a fair thing for people to pay for. I mean, like I'm recording. Here locally, I'm recording the Hangout with ScreenFlow, just as a backup in case the live feed to YouTube doesn't do its job. Anytime there's a major version, you go from a 4.0 to a 5.0, that's a paid upgrade.
Yes.
Anything that's minor, it's like a dot release, dot 1, dot 2, whatever, you get that for free. But if it's considered a major release, you have to pay for it again. And it's usually not. It's only a portion of what the original cost of the app was, so it's not like it's a big number.
For a desktop, I think we're used to seeing that. We're used to we get the free upgrades, the minor upgrades, the updates for free. But then when there's a major revision update that comes out, we see we have to pay for it.
Right.
And the App Store is starting to get used to that model, and eventually, even for my textbooks, I'll eventually move to that model that when there's a major change, that it's just so far there's only been minor updates based upon Corona SDK's updates. So I haven't felt justified in going to version 2.0.
Right. Yeah, I realize that these conversations have been going on for a while, and people you can never make everyone happy, but I think there are enough legitimate grievances, and if there are enough people talking about it, not just the developers themselves, but also when you go and listen to other tech shows and stuff like that, people are talking about it. The media starts to pick it up, and people start to complain about it, rather loudly. I think we'll see some changes. We had the same thing when. I don't remember who was in office, or so to speak, at the time. But remember when everything was sort of this textured design, the design language wasn't flat like it is today, and there was this sort of this, hey, what this needs to change, it's getting outdated, and things changed. It grumbled. People grumbled for a long time, but eventually it changed.
I don't know. I still don't like the flattened graphics.
You don't like the
flat
design?
Used to it, but I don't like it.
Yeah. Well, let's go ahead and get started. I guess it's 2:00. I mean, we're started, but we'll put a beginning on the show. That way we can chop it for the podcast. So.
2:00 in your part of the world.
Yeah. All right, welcome back to Corona Geek, here where we talk all about cross-platform app development using Corona SDK. I'm your host, Charles McKeever, and we've got a great panel today. We've got Dr. Brian Burton down in Abilene joining us.
Hello.
Also, we've got Ed Marino from roaminggamer.com.
Hey, yo.
And we've got Steven Johnson from ZibalbaStudios.com.
I didn't do it.
And I know, I
I'm
know,
not gonna do it
I'm
anymore.
still leaving the gap. I didn't say Dr. Burton's website, burtonsmediagroup.com. You can go check him out there. He does have a great book. We were talking about that just a minute ago. You want to check that out because he keeps it updated all the time. Anytime there's a major update, he has updated it, and everybody who bought the book gets it pretty much for free. I guess you can. I don't want to say free because it sounds like it'll always forever be free, but
But for the time being, I'm going to continue the model.
yeah. So lots of good biddies there. Does anybody? We're gonna get back into our desktop development series. We are 9 episodes in now, creating a desktop game. We've done everything from keyboard and mouse inputs to putting players on the screen to shooting zombies and doing tiled backgrounds. Today we're supposed to do pickups and traps, I believe, is our topic.
Right, we're going to do pickups and traps, and I'll let the other cats out of the bag in a second.
So
right.
if you haven't already, you can go over to youtube.com/coronageek. There is a playlist there that has all of the videos in it, and there are links in every one of the videos to show notes, and in those show notes are links to the code. You can download the source code and follow along. There is a version history sort of on GitHub if you want to go back to a particular version of the repo. You can go look at that, but you can basically download the full source code and play the game. Look at what we're looking at. So if you have any questions, go back and watch the previous episode on that particular topic so that you can get up to speed. Anybody have any announcements before we start? No? Ed's shaking his head. No?
I wish I had announcements.
Since we mentioned the book, I am working on an update to it now, so I'm taking suggestions, or if you found a bug or there's a problem, please send me a quick email and I'll be happy to make those adjustments so that it's included in this next revision of the book. I'm also looking at including patron accounts to go with it, so that those who've been enjoying the book for some time, one book's been out there since 2011, the other one's came out last year. If somebody wants to buy me a cup of coffee, I'll be more than happy to accept it through there. So I'll be passing that out sometime within the next couple of weeks.
You know, I think the Patreon thing would be great. It would be a great way for people to buy the book and then continue to fund its maintenance and development, because if you buy a book off the shelf in the bookstore, it's done. There's no future updates unless you buy the book again.
Right.
So yeah, I think that's a great way to go.
Yeah, you could do just an idea here. You could do you got different patron levels. You could do a patron level, whatever it is you want to sell the book for. So the regular price of the book. Mm-hmm. And if they're a patron at that level, they get the book for that month. But then maybe people will be like, oh, okay, good, I got the book, and they can adjust back to just no money, or they give you some like a buck a month. But you can make the deal, instead of everybody getting a free upgrade, you can only get a free upgrade if you're an existing patron with the book.
Right. Yeah. So you have a one-time investment. Is that what you're saying?
Yeah.
Where
you one-time investment where you
all I have to do is commit to this one-time thing, but for an extra 99 cents,
you get updates
or whatever.
Of course, you pretty spoiled everybody by doing here. You get updates anyways, but now we're talking new customers.
Yeah. New customers. Yeah, you can have
new customers shift in the system, and
yeah. And then you can have
a month, and you get the free updates every.
Yeah, then you can have stretch goals, just like with the.
Oh yeah.
Ground-funded
new
stuff.
chapters and.
Right. I think we're kind of sounding like we're joking, but I think it's
around a little bit. But you could do that.
I think it's valid, for sure. Well, if nobody else has any other announcements, I will mention that there was a blog post went up last week announcing Corona Ads private beta. So if you haven't seen that already, go over to coronalabs.com/blog, and there is a blog post there on December 11th. That talks all about it. There's a form that you can fill out and get on the list, and I think that's something that you should do. Also, if you haven't seen the interview that we did with Raj, there are over 800 views on the video between the Corona Labs and Corona Geek channels. We put it on both, and that was a good interview. It was about 24 minutes long. Raj answers a bunch of community questions, everything that came from the forums and from blog posts and emails and stuff like that. So go check that out. That's on the blog as well. And of course, we'll put links in the show notes directly to everything as well, so you can go right to it. And then the other exciting thing is that tvOS and desktop's getting close to being out of beta. At least the OS 10 is, and I'm pretty sure Win32 is right behind it. And then tvOS is all the pieces and bits and pieces are coming together for tvOS. So like iCloud support, being able to put image assets, being able to put icons in, having top shelf images, all that stuff like that. So that's all coming along as well. So you can read about that. There's actually a tutorial on the blog on how to add icons top shelf and launch images for tvOS. So if you're kind of into that thing, you got something over the week or over the holidays you want to experiment with, this would be a good time to do it. Hey, there's Sergey. Well, Ed, do you want to
Launch?
Yeah, kick us off?
I'm ready to launch. Let me switch over to my desktop.
I'm okay. You're Jodie Foster in Contact. I'm okay to go. I'm okay. Do you remember that movie?
That's a bit old for some of your audience.
Wow. You think so? You know what I'm talking about.
Yes. I do think so.
Are you kidding? It's on Netflix.
Jodie Foster?
Yeah, Jodie Foster. These days it's on, there's Netflix. You can just Google it. Just search it. Just Siri it.
Okay, so I'm going to give you the rundown on what I put in here, and I'm going to give you a summary of what we're going to cover today. We're going to do kind of a sprint like we did last week, but we're going to cover the important parts. Okay,
this is getting fancy looking.
Say again?
This is getting fancy looking.
It's as fancy as it's going to get, and after this, people have to modify it to their own heart's content. This is all you get. There's a little more here. You can't quite see it all. What was I going to say? So this is week 10, week 11. That's going to be it. If I have my say, and I will, my say is that next week is the last week on this game. And just as a teaser, what we're going to look at next week is we will look at joystick inputs instead of keyboard. I will hook that up and show you how to do it. And then I will give you a quick overview of the entire game in terms of just a review of a document, which I haven't quite finished, which people will be able to use. And the way the document is set up is it'll have screenshots in it, and then it'll have highlighted sections. For example, like let's say the player is highlighted, and then it'll have references to the different bits of code that you have to look at to understand that particular thing you're seeing. So if you want to see how the HUDs work, you find the page in the document where the HUDs are shown, and then it'll give you file names and perhaps functions, etc., that you need to take a look at to understand how that bit of code is working. So having said that, this week's additions are a very basic HUD background. I realized that we had these HUDs last week, but when I introduced some new features, you couldn't read them anymore. Sounds. We now have a series of sounds. You won't be able to hear them. That's the unfortunate thing with Google Play. But we've got sounds for the zombies, arrow firing, and a background music track. This uses the same code that we used in previous games, so I'm not going to go through it other than just to point out where it is at. It's very simple in terms of how it is used. So if you're confused at all, go back to our old shows, or wait for the document from next week where I will have a section about sound, and you can just look at the document. It'll take you to the right code and show you what's going on. In addition to that, you can see my screen, yes. I have added the forest border. So you'll recall previously we had a red area around the no-go. So once you got to the edge of the red box, you couldn't move anymore. That is still true, but there's no red box, there's no red border. Instead, what I've done is given, let me see if I can get a little closer here without getting killed. I have given randomly generated forest area around the play zone. And the benefit of this is twofold. One, it delineates where you can and cannot go. It makes it a little more logical. And also, it hides the zombies as they're coming in. So you don't want to be right up against the edge of the forest because you're not going to see death before it gets to you. So we'll demonstrate that a little later on a higher level. Let's see what else. Right, of course, I put in the drops. So we've got the pickups. We already had those last week, but I'll show you how that code works this week. The essence of it is when you shoot an enemy, you've got a 20% chance that that enemy will drop a chest. There are 3 colored chests, and each chest color corresponds to one of the 3 pickup items, which are all traps. The first trap is a mouse trap. The second one is a spike, and then the third one is a leaf, what's called a leaf storm by Reiner. It's Reiner's artwork. And I'll show you how each of these traps works in a moment. I'll demonstrate them so you can see the play value of each of these. Each of them has different strengths and values. In defense, they're all for defense, self-defense. Let's see. Last week we also had, but did not discuss the gems. The concept here is a very simple level progression concept. There are 4 gems per level. There's a HUD at the top indicating that you have currently not picked them up. It has a gray border. That means you did not get it. Let's go ahead and restart. And I'll pick one up so you can see it. Let's pick up the white one. So we picked up the white one, and our white HUD turned green. When we get all 4, it progresses to the next level. The way it does that is it simply redraws the level and increments the level counter and moves on. So I'll just demonstrate that very briefly. Let's go pick them up. And it places the gems randomly within the bordered region. So we got one more somewhere here. Here it is.
Drawing you to the edge of the forest. See it?
Sir?
Drawing you to the edge of the forest?
That's right. It's the way the algorithm was put together was that it tried to be as close to the edges as possible, but then it gave a little randomness to that, how close it was. So it's randomly placed, but with a preference to be near the edges. That way you have to run around and risk yourself a little bit. You have to be strategic, thoughtful. Okay, so let me just jump right into the code. We'll get through the boring bits. One of the things I promised in a previous week, and I did finally, is I have completely removed the need for SSK. I went through all of the code, and what you'll see checked in today, we'll still have this line in main, where you could require main, or require SSK if you wanted to, but it is no longer used within the code. I've kept it around purely because I like to use some of the debug features in SSK, and that way I can quickly enable it again and use those debug features. But as you'll see, it's commented out, and the game runs fine without it, which means that I replaced all of the functionality that was previously dependent upon SSK with regular Corona code, which you'll find in the project. Let's see. You'll see at the bottom here of main that the section for the sound has been enabled for this demo. I'll go ahead and commit it like this, but for the rest of this time while we're talking, I'm going to turn it off. But the essence of it is very simple. It requires a sound manager. It calls sound manager init, which within the code, what that does is it will preload all the sound effects for the zombie sounds and the arrow firing, get them all ready. And then I call enable SFX, which is the function to enable the sound effects. So if I did this, what would occur is it would still catch the events for playing sounds, but because I haven't initialized the sound effects engine or turned it on, it won't play any sounds. So it's basically a toggle, a very rudimentary toggle to turn on and off the sound effects. Similarly, it's a very simple soundtrack method. It's only got one soundtrack that it plays, if any, and the way you do it is you simply call sound manager, play soundtrack, and then you point it to an MP3 or an OGG or a WAV or whatever it is you want to play. And I chose just a random bit of music from Incompetech, which there is a link to in the code. And he's got royalty-free soundtracks that you can use in your games with credits. So that's the key. You must give credits if you're going to use any of his soundtracks. So, but for now, I'm going to turn this off. I'm going to turn that off in 2 lines, and now we have no sound. You probably couldn't hear it anyways, but I hear it over here. It's kind of annoying. So it's annoying for me to have sound and talk at the same time. So, because then I've got multiple sounds coming in and out here. Another bit of just bookkeeping here. I'm going to go on to showing you how I made the forest quickly. I'm going to do the small bits first. But before I did that, one of the things that I decided to do was I realized as we progress through this game, let me play a little bit and pause it and show you what's going on here. Let's get a zombie out here. Come on, zombie. So kill the zombie. All right, let's do this. Oh, that was nuts. Why did I do that? Okay, good. Come here, zombie. Let's fire another arrow. Okay, so we got a lot of visual elements going on here. We've got the HUDs. We've got the indicators on the HUD. We've got the player. We've got the background. We've got the forest. We've got the gems. We've got our reticle, our arrow. We got the zombies, both walking and dead. What starts to happen here is when people first develop their games, typically what they do is they just throw everything into one display group. And then they run into this problem where certain things are rendering on top of other things, and they're getting rendering layering issues. So having been through this whole exercise before, I set us up with, and you can see it off to the left here, I set us up with a layering system. And the concept of this layering system is you have the current stage, which is the single group that Corona creates initially that everything else lives in. And then I created a series of groups, one called background, another one called world, underlay, one called content, another called overlay, and then interfaces. Now, you see more, and I'll get to them. And then what I did was I organized them in such a way that current stage was on the bottom, and if you proceeded through this graph, you could see that background was next, the world, then the world contained underlay, content, and overlay, and then finally interfaces. That was great. Up until last week, we had enough layers. They were organized in such a way that I could put certain content and certain layers and always get the rendering effect I wanted. But this time around, or last week, I started to do some additional stuff. I worked on the HUDs. I was adding the gems and I was adding, the chests and the traps, and I realized I needed a couple more layers. So what I wanted is I wanted the enemies, for example, you shoot them, and I wanted them to go into their disintegrate animation and then just sit there for a while. And they'll hang around on the screen for about, 60 seconds or so. And what I wanted was these piles of bodies everywhere, but I wanted them underneath all the other moving objects. So originally I was keeping them in the content layer, and then what was occurring was they would layer on top of gems, and it was starting to be a little bit chaotic. So what I did was I added a new layer called dead enemies, and when I kill an enemy, when I start running the animation for disintegrate, I will simply move it from content into the dead enemies layer, and that will push it down a little bit within the rendering stack, and then anything that comes along afterwards, or anything that was created in the content layer before that, will then be on top. So, for example, let's see if I can manage this. Let's find a zombie. Oh, zombie, would you please come? Where are you? Here we go. Here's one. Okay, let's see if I can shoot this guy at the right time. So I'm going to shoot him. Right now he's over the gem, and then, too late. It's hard to do, but I would encourage you to do this. Let the zombies walk over one of the gems and then shoot it, and you'll notice that when it finishes the disintegrate animation, the gem will be on top, whereas previously the zombie was sort of like walking over it. And that way you don't lose track of the gems and the chests. This is especially important for the chest drops, which we'll get to in a minute. On top of that, I created another layer called items, and the gems, the chests, and I believe the traps all go into items. And then content, which is where the player goes, is that's the player and the arrows go in content, and that way they're always on top of everything else, except for other moving NPCs, enemies. The enemies and the player, when they're moving, are in content. But when the enemies die, we move them down to dead enemies, and our layering is controlled in such a way that it's all nicely organized and not chaotic. It doesn't interfere with the game. So that was a little bit longer than I wanted, but the premise here is basically that when your rendering situation gets more complicated, you may find yourself needing to add more layers, and if you use the strategy which I've used here, it's very easy to create a rendering system where you can add more content layers and use them at any time. So let's talk about the Forest Maker. Let me take you up to the forest again and show you how it looks. Let's get up here, right up in the corner. So the premise of this Forest Maker is that we want to render the forest everywhere except for within the play area. And what we want to do additionally is we want to give it sort of an organic feeling. And when I say organic, what I mean is these trees are actually all aligned on a grid system. For every block, there's one tree or one bush. And when you do that, in fact, I will turn off the randomization portion that makes it feel more organic. And you'll see what I mean about a grid system. Let's go ahead back up here. Yeah. And let's do this.
So the forest is randomly placed or generated?
It is not randomly generated.
Oh.
That's what I'm trying to demonstrate here.
Okay.
So it's laid out on a grid. This is how it's initially laid out. Very grid-like. This is where it started. So let's back up. First of all, Forest Maker is exactly the same code as, where is it? Ground Maker? Yeah, Ground Maker. I derived it from Ground Maker. And what I did was I said, lay out a grid, but if that grid hits one of these places, basically it's within the limits, which is the limit, the bounding limit for this area. If it's within there, don't render anything. So create something if it's outside the limit. If it's inside the limit, create a tree. And that's what this little piece of code here does. So this is slightly different from the Ground Maker code, so you can compare the two side by side. But assuming that you get into this code and it's okay to create a tree, you randomly select one of 32 trees, and there is a sprite sheet that has 32 trees. You choose one of those, and then you place it at the current XY grid that you are normally going to place a ground tile at, because it's the same code, similar code. So we'll place a tree, and as you can see, it looks terrible. I mean, it's clearly artificial. So the first step to making this less artificial is to keep our current XY position, but add a little bit of randomness to it. So what we're doing here is we're saying the X position is going to be our current X plus a random value between -10 and 10. Similarly, we're going to do the current Y, -10 and 10. And then when we run that, now it's going to look a little bit better. So now it looks, you can see that it's no longer grid-ish. I mean, it's still a grid, but it's no longer perfectly aligned. There's slight deviation. But that's still not good enough. The other problem here is the trees are significantly smaller than what we need. And so experimentally, what I did was I said, okay, instead of making the tree size the same as the grid, choose a random number. And if you're not familiar with mrand, mrand is my localization of math random. So it's just a shortcut for keeping me from having to type that every time, and it gives me a slight speed up because I've localized the function. So mrand 2 to 2.5 multiplied by the grid size. In other words, the trees, every time I place one, it's going to be within 2 to 2.5 times the grid size. And as soon as I do that, I get, did I save it? No. I save it and do that, we get this. Now, it feels much better. It's a bit crowded, honestly, but as a first pass for a very simple algorithm for placing a bunch of trees which bound our area, which is all I wanted to do, and I also wanted to give you just a few gaps so you can kind of see that the zombies are coming sometimes, but not always. This works just fine.
Yeah, it has an organic feel to it.
And it has this organic feel because the sizes all vary slightly. The placements all vary slightly, and we randomly choose our trees. So clearly I could have, some of these trees don't go with some of the other trees, like this tree here doesn't really go with the deciduous and whatever. But the point was to get something in there fast and furious for the demo today. People can refine this to their heart's content.
The reason I was asking about the random part was that Stephen had said in the comments he was thinking about how to make the trees look like they're rustling using some kind of shader or color alpha.
Oh sure, give me more work to do.
Yeah.
You could do that. You could do that, or you could here. We could take that one level up. You could have the trees that are near the zombies rustle.
Oh, that would be cool.
See, because then you'd get this clue. You'd see a rustling, little rustling on the edge of the tree, the boundary. You'd be like, oh, gotta get myself away from there.
That's where the velociraptors are.
Yeah, I'm thinking there's a lot of structure. There's the shadow at the bottom. There's a trunk is about half of it, and then there's foliage on top. You could exploit those ratios a lot.
I'm glad you mentioned that, because actually I didn't show this in the code just now when we were talking about it. But when I render these trees, I render the tree with no shadow. So I've taken the image that was originally in the Reiner set, and I cut out the trees and took the shadows out. So I render those in one layer. I render those in the overlay layer. And then in the underlay layer, where the ground goes, is where I put the shadow. So if we're looking at the Forest Maker, you'll see me do that. I create the tree image, which is like the green and brown and all that, and I put it in, I'm sorry, tree sheet. No, I create the shadow, and I put that in the underlayer, and then I take the tree sheet, which has the trees with no shadow, and I put them in the overlay using the same selected tree number. And so when you see the zombies walk over this, I got there a little too late, but you would see the zombie being on top of the shadow but underneath the tree, which gives it a much nicer feel, because otherwise you'd see shadows on top of the zombie. So we could do that, and then we could shake the local shadow / tree, and so you'd get a real nice effect for when the zombie is nearby.
Yeah, that would actually simplify what I was thinking, because you wouldn't have to try to merge the two.
Yeah, I didn't want to deal with the, there is an issue here with any kind of isometric relationship or whatever, is like, when do you put the zombie in front of the tree or not in front of the tree? And I completely did not deal with that. So if you look at it enough, you'll see that the zombies are just coming right out of trees sometimes. But you know what? The point of this game is that you're going to be so busy trying not to get killed that you're not going to be noticing little details like that.
That's totally unrealistic. Zombies don't act that way.
Yeah, zombies don't come out of trees; they come out of the ground. I know. Okay, so what's the next deal here? I'm gonna ramp up the difficulty a little bit here so we can get some more zombies on the screen. And if people will want to remember this, is look for start level in common. I'm gonna put this up to 10. I don't want any archers, but I do want to get a few zombies on the screen. Actually, let's make this 14. Level 15 is when you first start to see archers, and I don't want any of those guys because they make my life difficult. Okay, so let me get some guys on the screen here, and I'll shoot them, and hopefully we'll get some chests out of this deal. There we go. We got a chest. Okay, so what happened there? We've already got all the code. We talked about this before for generating the enemies. Last week or the week before, I talked about how I elaborated upon the original code for generating enemies. And now we generate 3 kinds of enemies with different characteristics: the seeking versus the walking versus the continuous seeking, etc. And then, the archers, of course, who seek a little bit and then they fire an arrow and then they seek some more. But no archers right now. But on top of that, what I wanted was the ability to add a pickup system. So I added some code for creating chests, which I'm going to show you in a moment. And the way it works is if you shoot a zombie, the arrow code, which is created in the player code, will know that it has hit a zombie because it has some checks, and then it will randomly drop a chest 20% of the time using the chest code. And it's worth noting before I proceed that there are other ways to kill zombies. Another way to kill a zombie is to have an archer shoot an arrow, and that arrow will hit a zombie and also kill it. So archers can kill zombies and you kill zombies. But when archers kill zombies, their arrow code does not create chests. So you don't get chests for zombies killed by archers. You only get them when you kill them yourself. Additionally, each of these traps, when we introduce them, you'll see that they can kill zombies and archers. But they don't drop chests either. You only get chests for shooting enemies with your arrows. So it's a balancing thing that I did so that you didn't get reliant upon using your traps and then sort of like get more and more chests and never have to use your arrows. So you have to think all the time. Don't run out of chests. The only way to not run out of chests and therefore pickups is to use my arrows. And so I have to use both my traps and my arrows depending on the situation to keep myself going. Okay, so let's get on to chest making. So chest making. All right, chest maker, first of all, is another sprite generation piece of code like the ones we've looked at before. It uses the sprite maker as the basis. It has a very similar setup. We've talked about this before, where I load up the chests info file that is generated by Texture Packer, and I get the sheet information, and then I create an image sheet using graphics new image sheet and the information that I just loaded from the Texture Packer file. And then I create a set of sequences, and for this particular case, all I wanted was chests with no animations. And so I went through the list of possible chests that were in this much larger set, and I pulled out the blue, the white, and the red chests. And then I selected the frames that would do nothing more than just sit there. They just sit there. The lid doesn't open, nothing. And I wanted them facing forward. So what we get is chests that look like this, but they're red, white, or blue. And it's worth noting at this point that I'm not sure why, but the Reiner set has some naming issues. The blue chests are blue chest, whereas the red and white ones are chest space white. So it was a little bit more work to set up the naming. And so what I did was I set this bit up just like I did previously, where I said the anims, which is our list of animations, blue chest, and these are the frames that I want. It has 9 frames. Look for this keyword. That's what that's going to be doing. And then it needs to play for 900 milliseconds and loop 1 time and then stop. Let's see. And then I call sprite maker generate sequence down here, and that uses this information and this information to find the front-facing blue chest or the front-facing chest white or chest red and build those into animation sequences. Now the trick is that when you wanted to place a chest, normally I would just be able to say place blue, place white, or place red, but because the names were different, I had to have a bit of code down here. So this is a departure from our other code examples that we've done before. If it was blue, I said set sequence blue chest front, which is just how the names came out. If you look at the source, you'll see these names in there. But if it was one of the other 2 colors, then I had to put the chest in the front and then color, and it comes out as chest space color underbar front. It's kind of goofy, but I encourage people to go open this file right here, images Reiner's chests, and they'll see that blue is set up one way, but the white, red, and the yellows and the other ones are all set up the other way. So that made this whole example a little more difficult than it needed to be. And in retrospect, maybe I should have gone in and renamed everything just to keep it consistent, but I didn't.
Yeah, I was going to ask if there was a reason why you couldn't.
No, I could have literally gone in and renamed these things, just gone and corrected the code in this file right here, and it would have been fine. Okay. But I didn't think of it at the time. It was just as easy for me to handle the special case, which is just this little tiny piece of code. This was quicker than going through and validating that I didn't goof anything up in the other file. And there's one other thing. Let's see. Is there anything else? No. Okay. So when we use this, we're going to call it, and we're going to say drop a chest, and we're going to pass in a color, a string, blue, red, or white. And you'll see that in a moment. But let's go ahead. Yeah. So in the enemy manager, where we create our enemies, that's where we have the drop chest code. So the drop chest code is going to be called from somewhere else, but I put it in the enemy, and the reason I did that was because if I have it here, then it's both logical because the enemy is doing the chest dropping. It's gonna. When I say chest dropping, what I mean is it's creating a chest and is putting it into the level. And because it's here, the enemy knows its own position, and I want to drop the chest wherever the player or the enemy was when it died. So this code is quite simple. What it does is, if we look in common, chance to drop, let me just take a look here. Find the code. There it is. If you look in common, there is an enemy setting called chance to drop. It's set to 20. And if we go back to the enemy manager, you can see that I say, give me a random number between 1 and 100. And if that value is greater than the chance to drop, oh, you know what? I think I've been saying 20% all along, and I've actually got an 80% chance to drop a chest. Yeah, this is an 80% chance of dropping a chest. So in other words, 80% of the time, the random number, if it's evenly distributed, will be greater than 20. So if I really wanted a 20% chance, I need to actually make common, keep losing it here, common, I need to make this 80. So does this, I hope this makes sense, but if you've got a range of 1 to 100, 20% of the time, that's going to be greater than 80 if it's evenly distributed. But I'm going to put it back to 20. So what we've really got, let me correct myself, is an 80% chance of dropping a chest. In reality, it doesn't quite work out that way because the random distribution is not 100% even, but it's close enough for government work and for the show. So there's really no way, there is a way to improve this with a technique that is called a something bag, and I can't remember it. It's a different way of getting random values where you pre-select them and you get exactly the ones you want, and basically what you do is you shuffle this list of random values, and then each time you pick one out from the front of the list until your bag of random values is empty. When I say bag, it's just a term. It's like having a bag of dice. You got 3 red ones, 2 yellow ones, and a blue one. You just reach in and you pull out a die until the bag is empty. You know you're going to get 3 red ones, 2, whatever the heck I just said, I already lost it, 3, 2, and 1. You know that that's what's in the bag. So the distribution is fixed. The order you get them in is still random. So the problem with our technique here is the order we get them in is random, and the distribution is pseudo-random. It's not controlled. We don't have an even distribution. We don't have a known distribution. We're relying upon the random generator to produce an even set of numbers and give us the distribution we want, but it's not guaranteed. So we should definitely, I could demonstrate this in a future show if somebody will help me remember. I'll just write a note here, because it's a useful technique that only takes a few minutes to demonstrate how to do. It's I know I should move on, but I just want to say that that particular technique is especially useful for things like card games, any kind of board game, something where you want to create a very clear, even distribution of choices and options and chances for people. But like poker, things like that, that would be a case where you'd need to set up this kind of technique, because you could not rely upon random distribution to always give you the correct cards out of a deck. Okay, so we're dropping a chest, we're writing the function. I'll show you where it's called in a minute, but the enemy function, it's just a function. We take our enemy object and we create a function called drop chest. We see here if our number is greater than the chance to drop. Assuming that it is, we continue. If it's not, it returns, it does nothing. So we call this, if we get a number that's greater than chance to drop, we quit. Oh, you know, now I got to reverse myself again. 80% of the time it's going to be greater than that. That gives us a 20% chance to drop. I'm sorry. Okay, so anyways, the next step is we set up some arrays, or tables. I create a table of chest colors, red, white, and blue. I select one of those colors, and the way I do that is I randomize between 1 and the number of colors. This is not very efficient code, but it's easy to read, therefore I did it this way. And then I select that number out of chest colors, and then at this step, this will contain red, white, or blue, a string. I get the layers, because I'm going to use them, and then I call chest maker, and I say create a chest, put in the items layer, put it at the XY position of self, which is the enemy at this moment, and make the chest of the color that I just selected here. So make a red, a white, or a blue chest, and our code will execute. Then all I need to do is add a body. I'm adding a physics body because I want it to be collidable. I want to use collision detection to be able to detect when it's time to pick that up when the player touches it. It's worth noting also that I added some additional collision detection settings here in common. So originally we had the player, we had one called enemy, another one called, I believe, arrow. I have created more of these to have a more refined collision detection setting. And so the way that works is the player can collide with the zombie type object, the skeleton type object, the skeleton arrow, a chest, or a gem. A zombie can collide with the player, player arrow, skeleton arrow, and traps. And then the skeletons can hit the player arrow, and the traps, but they can't be hit by skeleton arrows. Skeleton arrows will pass right through them and not kill other archers. So archers can kill zombies, but not archers, and they can also kill players. Whereas the player arrow can kill zombies and skeletons. So this is how we get a very quick. It's worth noting, and I think I said this before, that doing this by hand is a kind of a painful process. You'd have to set up a number of these values, do the math, hopefully you didn't make a mistake. If you did like I did, you'd come along later and go, oh yeah, I really need a chest type, or I need to add some traps, or I want to add an arrow that only does certain kinds of collisions. And this is the point where you got it all set up the first time. It's all working. And then you come along later and you go, oh, I need more. And that's when you make the mistake. This is why I made the Collision Manager plugin, because as you can see, it was quite simple for me simply to add more names representing a collision type, that is the body type that I wanted, and then to set up the rules. To say, oh, the skeleton collides with these things, the player collides with these things, done. I don't have to do the math. All I have to do later is call the Collision Manager and say, give me the right numbers to plug into the engine. And so on that note, I add a body to the chest object. I make it dynamic. I give it a radius of 10, just sort of randomly selected, big enough so that it overlaps the visual part that we're going to see. The density doesn't really matter. In fact, I could just take this bit out here because it's not going to be moving. Let's see what else. Or I could have made this static because I'm not going to allow it to move, but let's just leave it alone. And then here's the key part, filter. I say I want to set the filter. This is the part where we used to have to do math. Instead I say collision calculator, just give me the filter for the object type chest. It does a little lookup in a previously calculated value and gives me a table containing two numeric values that get put into the filter. Easy peasy. The only other thing I do here is I mark the chest with a field called collider name, and I make that collider name chest. Now the reason I'm doing this is it's a flag so that later when a collision occurs, I can look at the object and go, what are you? And because I've marked the collider name field chest, I can say, ah, it's a chest. So I need to do something special because it's a chest. Or I need to do something special because it's a skeleton arrow. Or whatever the case might be. The rules of my game, the way my code is written, would control what I need to do with that. So this is just an indicator, a flag that I can use later. I may never use it. It depends. But having it, at least I have a way of detecting this and saying, ah, this is a chest. Let's see. The only other thing was chest to back. We don't need that code anymore. That's old because I'm now using the item system. Previously, I was putting these into the content layer, and I wanted to make sure that these were always below the player because the player was created previously. So I pushed them to the back, but I'm not doing that now, so I took out that push to back. The only other thing I really have to do here is I'm going to skip. I guess I won't. I have to choose, based on the color that I previously selected, what this chest is supposed to represent when the player walks over it. So blue chests give us one mousetrap, white chests give us the leaf storm, and the red chests give us the spike trap. So what I do is I mark a field on the chest called my pickup. Again, I'll use it later in the code, but at the time that I do the collision detection for this chest, I will say, what's your pickup? Oh, mousetrap. All right. Increment the mousetrap HUD by 1. Give the player one more mousetrap in their inventory. Move on. What else do we need here? Let me see. Yeah, okay. So this is the collision handler for the chest. And as I was saying here, so what it does is it says, first of all, let's get the other, the object that is colliding with the chest. So self is the chest. Other is the object that is colliding with it. Get the collider name. I set this field up for all my different objects. And it says basically, if the collider is not the player, then return false. Now I want to point out at this point, this code is completely unnecessary. You know why? I put it in here because people do collision code differently from me, and this is a good way to refine your collision code. If you only want one kind of object to be detected, you could do it this way. However, if we take a close look at our code here, you're going to see that the chest can only be collided with by one object type. Only the player will ever collide with the chest. Zombies and skeletons do not. Arrows do not. Other chests and gems do not. And because of that, this collision code will only ever fire if a player collides with the chest. No other object type will trigger the collision detection code in the first place. So this is sort of like redundant. This would function just as well without this line. Again, I put it in here because other people may find themselves needing to refine their collision handlers to do one thing if it's a player, to do another thing if it's an enemy, etc., etc. And simply by marking objects as their type when you create them, then you can look at the other collider name or whatever you want to call your flag value and say, ah, it's a player. Oh, it's a enemy. It's a bullet. And do something different based on that. All right, what else do we do here? The very first thing I do is, because I'm not looking at the phases, as soon as a collision occurs, it's probably going to be a began phase. In fact, it should always be the began phase. But I don't care. The very first time I get a collision event, I'm going to remove the event listener and stop listening for events, because that's it, I'm done. I'm going to pick this chest up. It's going to go away. Very next, I remove the chest. However, actually for better coding style, I probably should put this later. It doesn't make any difference. It's an interesting note that although I've said display remove, at this point, all the fields on self are still there. It's not until the next cycle that that object will get cleaned up anyways. So having it here versus having it here makes no code difference to any field, any custom fields I sent. However, I think it's probably better to delete it at the very end after I'm done operating on it. So check the pickup type. If it's a mousetrap, increment the common traps counter for mousetraps, which is where I keep my counters. I keep those in the common. I keep those in common so that everybody can see them. And when I say everybody, the player, the HUDs, the other traps, etc. It's just a nice, easy way to centralize my data storage. And let's see, where's counter? Searching. All right. Trap counts. All right, so I got a field here called trap counts, and I got one for mousetrap, one for storm, and one for spike trap. So if the chest is for mousetrap, I increment the counter by 1. Same for leaf storm, same for spike trap. And the only other thing I do is I post an event. I dispatch an event using my own custom dispatch code, which I've shown before, called onSFX. The sound code is listening for that, and it will receive it. It will parse out the SFX name and just play a random noise that I selected. These are not great noises, and people who want to elaborate on this code later should definitely replace these noises, but I had to have something as a placeholder. So coin 1 from some other collection of sounds I made sometime in the past, coin 2, and coin 3. That way, when you're playing the game, you don't necessarily have to see. When you're playing this game and it starts to get fast and furious, if you have a distinctive sound for the different chests and therefore the traps that you pick up, you won't have to be looking at your trap counters all the time to know what you've got. You'd be like, I really need another leaf storm. Bong. Well, I know that sound means I just picked up a leaf storm. I can use it instead of having to look away from what's going on the screen to your HUD. Okay. Let's see here. I'm not going to cover the HUD code today. I will say that it is in a function called draw HUDs in the game file, and it's relatively straightforward. All I do is create some images and some counters and stuff like that, and then I add enter frame event listeners. And the enter frame event listeners will go through and look at these counts, and every frame they will change these little counters under here so that they reflect the number of traps that you currently have in your inventory. For example, if I were to walk over this white one, I think that's the leaf storm. Let's go ahead and kill this guy. There. So we walked over the trap. That code incremented our leaf storm counter by 1, and the very next frame, the enter frame in the HUD's code, said, hey, oh, that's changed, so let's change the value of this counter on the screen. That's all it does. It's not used for anything else. It's purely to reflect visually how many you've got. The other thing that the HUDs do is they show you which trap you have selected as your drop trap. So if I were to right-click on the screen right now, I would try to drop a mouse trap, but because I have none, nothing would happen. All of that code is in the HUD code, and so if people want to see how that is updated, they should take a look. And it's also worth noting that when you click the tab key, tabbing will go to the next one, and then you tab again, it will go back to this one. So 1, 2, 3, 1, 2, 3. You can only have one drop selected at a time. Okay, so we've created the chest. We dropped it. Let's go ahead and deal with how the player picks it up. I'm sorry, we already did that. We've got the collision code. That leads us to drops. So let me demonstrate some drops first. And the way I'm going to do that is I'm going to start us off with an inventory of 10. So I'm going to go into common, and I'm going to look at line 48 through 50. I'm going to set my initial mousetrap, leaf storm, and spike trap counts to 10. Then when I restart the game, you'll have 10 of each. So for the purpose of this demonstration, I can drop any trap I want. So I'm going to drop a bunch of mouse traps, and you can see how they function. I do this by walking anywhere I want and right-clicking. Right-clicking drops the currently selected trap. Now I think that as soon as I unpause this, I'm going to die because he's going to be a bit close, and I may have messed up here. But what's supposed to happen, as soon as this dude hits the trap, he's walking towards me, the trap will trigger, it will kill the zombie, and the trap will destroy itself. It's a one-off trap. So let's go ahead and, you know what we'll do? I'll restart this and make a ring of these around me. So there we go. Now we can see these guys walking into it. Boom. So one zombie, one trap. They're sort of useful, but they're kind of lame too because you can't kill multiple zombies with one trap. However, if you want to kill multiple zombies with one trap, you can. In fact, let's just get these guys rounded up into a circle first. That'll make my life easier.
It'd be cool if you could trap the zombies, convert them into zombie soldiers, and then send them out against the other zombies.
There you go. That's my next. Okay, I think they're close enough. Now I'm going to start dropping these things. So these start running, and they kill multiple zombies. They have 3 lives each. So 3 zombie deaths. 3 zombies collide, and by the time 3 zombies collide, then they destroy themselves. So 1, 2, 3, and then they're removed from the screen. So should destroy one of these already. That one got destroyed because it killed 3 zombies. This one should probably go too. Ugh. A little bit hard to keep track of.
Which is cool because they're not limited by time.
Yeah, they're not limited by time. So the more of these you get. Oh, and by the way, I can walk on them all I want. Oops. Well, without walking onto a zombie would be good too. And they don't kill me. So, for example, let me just show you this again. My traps don't hurt me. Should give myself 100, you know, because that'd be like way cooler. Let's do that. We got 100. Now we got 100 because 100's better. Then I can really lay them out. So
Can you make them take an extra step before they heal over?
I could, but I don't want to. I could.
Maybe they're dying right in front of them instead of on top.
Yeah, no, I didn't make this code very sophisticated, like you're thinking there. Okay, good. I think I'm protected now. I can talk here for a while without. All right, chaos. Nobody's gonna get at me. But the point here is, you can see these are long-term traps that will protect you for a long time, level to level, which is great. But my favorite trap, and I'm going to reset this so you can see it, is the leaf trap. Now, the way the leaf trap works is it stays around for 15 seconds. It's got a limited lifetime. But it doesn't just stay there. It finds the zombie that is currently closest to you and kills it. Or it tries to. So let's go ahead and switch over to the leaf trap. Let's let some zombies get nearby. And let's just let one go. So it does its best to defend you from the nearest zombie. So you can, these are, I find, the best trap for when things get extremely chaotic.
Hilarious.
So the problem is they're also kind of dumb. If you have multiples of these going, they all go after the nearest guy. And so that's kind of good because they miss a little bit. Sometimes if they aim at a position, they're using the same AI that the green zombies use, in that they aim at the position the zombie is at, and then they go there. They don't keep looking at the zombie. So they say, okay, nearest guy, I'm going to move there. And in that time, the zombie has moved a little bit. So it may miss the zombie. However, because they move so quickly, they will, and sometimes they just go off on random rants and just get whoever is out in the forest. But the point is they move quickly enough to defend you in most situations. So when things get really hairy, you should be good to go. However, I noticed that as I played this, I sort of became dependent upon these guys, totally forgetting that the archers can get you anyways, because they stop off screen and shoot at you. So you're thinking, oh, I'm good. Nobody's going to get me. And then suddenly you die. And you're like, oh, yeah, I just got shot by an archer. That was good. I wasn't paying attention. So we're at noon. I'm just going to take you quickly into the codes. You can see we're at noon. We're at 1 o'clock, 3 o'clock, whatever. I'm going to show you the code that does this for the mousetrap. And then I'm going to let people take a look at the spike trap and the leaf storm on their own. They are fundamentally the same, but the leaf storm is by and far the most complicated piece of code between the 3 traps. And I want to kind of leave it as an exercise because people will look at it, and if they've been following along, they'll say, oh, that AI code looks just like the zombie code. And then, so they'll see the DNA samples here, in a sense, where I've picked up prior code and reused it to make this high-powered trap. But let's take a look at the mousetrap. First of all, the mousetrap has the same pieces of code that any other sprite maker has. It pulls in common. It pulls in the sprite maker code. I create a table called mousetrap. I could have called it public. I usually do, but in this case, I called it mousetrap. I load in the info, the sheets, the image sheets, all that good stuff for the graphics. I go through the same steps I always do to select the animation that I wish to play. The only animation I wanted out of the whole set was the forward-facing mousetrap. Let's go ahead and drop one, and I'll show it to you. The only one I wanted was the trap facing in this direction, and then as soon as I started it, I wanted to play the hinge moving and the little jumping, sort of like when a mousetrap fires, it jumps off the ground if nothing's on it, and that's what this does. So there are many more animations in the Reiner set, but I only wanted this one. So I set up the mousetrap, the base mousetrap animation, which has 9 frames. I wanted to play at 100 milliseconds per frame, loop once, and be done. I generate that sequence, and then my creator function is here. I, as usual, create a new sprite using the image sheet and the sequence data, just as I did. I select the front-facing animation, which is the one that I identified up here. And then I add a body. I make it dynamic, give it a radius of 20. I select a collision filter for traps. I make it a sensor, and the reason I make it a sensor is because I do not want it to get pushed around, and I don't want it to push the zombies. I merely want to detect the collision. In all other respects, it's simply in the world doing nothing, not interacting, not physically pushing on things. I mark it as a trap, and then I create a collision event. And the way the collision handler works is, in this case, I really do care if it's the began phase. I don't wish to accidentally fire more than once and start any of these other bits of code. Again, a piece of semi-redundant code. I check to see if it's a zombie or a skeleton. Of course, because of my collision code, it will only fire if it's one of these two. I could, again, comment this out, and the code will work the same. This is purely here for people who want to use a different methodology. All right. Thinking forward, I knew that the spike trap was going to have more than one triggering. It was going to be able to kill 3 zombies. So I said, okay, I'm going to take this code in a minute as I was writing it, and I'm going to use the same code over again for the spike trap. So I said, all right, let's just do this. Let's add a trigger count. And if the trigger count, let's see. What I said here was basically, if the trigger count exists, there's a field called trigger count, and it's greater than 0, do nothing. We'll return. Now, you'll see when you look at the spike trap that this is the very same code, but it says greater than 3. So if it's greater than 3, somehow we've gotten into this code again when we were not supposed to. Should not make it that far, but things happen. Things get delayed, removals get delayed, callbacks get called additional times. It's for safety's sake, I put this code in here to prevent us from executing the code multiple times. For the mousetrap, the very first triggering is the only triggering. For the spike, 1, 2, 3, those are allowed. 4, 5, 6, not. So once it gets over 3, you're out of here. Don't come back. Then I set a field. So if I get this far, clearly I don't have a trigger count field. So I set the trigger count field to 1. So the next time around, if it somehow gets back in this code, it will abort early. Then I create a sprite listener. Now the reason I set up a sprite listener is I'm about to start the animation playing, and I don't want it to do anything until the animation is done. And the easiest way to handle that is to add a listener and then listen for the ended phase of the animation. And since I'm only playing one, that's all I got to check for. Now if I was doing multiple, as the leaf storm does, you'll see me adding additional code in here that says what sequence am I playing? Am I playing the rotating sequence? Am I playing the disappearing sequence? The leaf storm has a number of different animation subsequences. But in this case, what I'm saying is I played whatever animation I just started. I got to the ended phase. That animation just finished. Now I'm going to use a transition, and I'm going to start immediately. I'm sorry, I'm going to wait 1 second, and then it's going to take 1 second because the default timer time is 1 second. I could just as well have said time 1000. So wait 1 second, and then over a period of 1 second, fade out from the current alpha to 0. In other words, wait a moment, and then make the trap fade out. And when the trap fades out, call whatever function is pointed to here, and that function is display remove. So from beginning to end, what occurs? You get in, you collide. Assuming you get this far, we mark the trigger to 1. We set up a sprite listener. We start playing the animation. The animation plays. It gets to the end phase. And then 1 second later, we start to fade out. 1 second after that, we finish fading out. And we destroy the trap. And the trap has been removed from the game. Done. Okay, so the other bits that this thing does down here below starting to play is it cancels the transition on the enemy. You remember when we shot the enemies with our arrows? What we needed to do was stop those enemies from moving. They were using a transition to move from point A to point B. And we wanted them to stop immediately as soon as they were killed. So the way we do that is we cancel the transition that is attached to the other, which is the enemy, which is being destroyed. So that stops their movement transition. We mark them as destroyed, and that's used by the AI code for the enemies. And when they see that marker, they don't keep trying to move the enemy. So we've canceled the transition, stops moving, and we've told the enemy, you're destroyed. Stop trying to follow the character. You're dead. And this is code we talked about before, but I just wanted to be clear. This is very similar, in a sense, to the arrow code. The only other thing left is, just like the arrow code, I have to play the correct animation on the enemy to make it look like it's falling apart, which is called the disintegrate animation. And if you look at the arrow code, you're going to see the very same code. I could probably have centralized all this, but I wrote this very quickly, so it ends up that I've got the same code in a few different places. And that is it. So our mouse traps are very simple. They sit there, they take one hit, they kill one enemy, and then 2 seconds later they're gone.
Very nice.
All right. So that is it. Next week, I'm going to come back with that document. I'm going to give you a brief overview just so you can see the parts. We're not going to go through the whole thing. I'm merely going to say this is how it's organized. And then we're going to spend the rest of our time looking at the changes that I will make, where we're now currently doing this with the keyboard. We will control this with a handheld joystick. I'm going to use the Xbox controller, the Windows controller for Xbox, but I'll be using D-pad and some buttons. So it'll be pretty universal as far as like PS4 joysticks or whatever people want to plug in. And I'll show you how to make that work with the joystick. And when I say joystick, what I mean is a controller. What's the right name?
Console controller?
Yeah, I think of it. Anyways, it's a normal D-pad plus joystick controller with buttons.
Yeah, right. There's a technical term for it, but we get that.
One more thing. I know we're over and you're about ready to close this down. Week after next is twin stick shooters. Unless things change, I'm going to come back with a partially complete to hopefully mostly complete twin stick shooter, which will derive from this code, and we will learn quickly how to do that. It's going to be very similar to this, so we won't have to do as much work to get a twin stick shooter working. And then I think we'll have satisfied 2 camps.
Okay, sounds good. I think this is good. So there you go. You need to go and check out the code for the leaf trap and for the spikes, and also review the rest of the code. One of the things I think is interesting as I'm looking at your screen here, Ed, is that each one of these functions, is a self-contained piece of code. There's you can kind of go through it beginning to end, and overall, the amount of code needed to accomplish this is pretty small. But I like to see how you've got your project structured on the side. So in your scripts folder, you have everything broken out into these more of a modular sort of mindset.
I try very much for that.
Yeah.
In addition to having a module for each maker, many of these are what I would call a maker or a builder. So you have a maker for the leaf storm, whose job it is to create the entire thing, animate it, place it in the right location, all of that. In addition, you'll see that I tried as much as possible, where it was redundant to write the code over and over, was to create a sub or a master, or however you want to think of it, a parent class, I guess, that did a lot of the heavy lifting. If we look at Sprite Maker, and I won't go on and on here, but Sprite Maker. Here's Sprite Maker. Sprite Maker is a relatively short piece of code, but it's 100 lines of code. I could have written that 100 lines of code every time I made one of these, or I could have created a module where I created the functions, did most of the heavy lifting in here, and modified the code here to do just the different parts. And so that's what I decided to do.
Okay. So I think it's good to see not only the concepts and the code and see how things are are coming together for the game, but also just to see how it's structured and get an idea of the project management into things, because that's always it's always a factor. No matter how well you think you've planned out the project, you still wind up having to manage all those little different pieces at the end. So.
Yeah, I believe that if people just take their time, and when they get the document from next week especially, they should be able to walk through the bits of this or look at the parts they care about and puzzle out what I've done. I mean, clearly it's going to take some time because this code is long and somewhat elaborate, but I do believe that most people of most levels will be able to puzzle this out fairly easily, just given enough time.
Okay. Sounds good. We'll be back here next Monday at 12 p.m. Pacific. We're going to talk about the controller, adding a controller so we can control things using an Xbox controller. So that sounds like fun. Until then, have a great week and happy coding.
Cheers.